Hello, welcome to part 5 of the Surds topic. Today's heading is binomial products. Now we know the word products just means multiply, but what about binomial? Well, we've actually seen binomial products before. Binomial products are where we've used FOIL. Okay, when we have two things added together, or two terms, and they're multiplied by another two terms. So let's write a little definition. A binomial product is of the form A plus B times C plus D. Okay, so that's where we've got the brackets there. And we can expand this using the FOIL method. Now, what does FOIL stand for? Remember that FOIL is an acronym where each letter stands for a word. Let's recap that off to the side here. FOIL. First, outer, inner, last. Alrighty, so if we have a look at an example such as A plus B multiplied by C plus D, and we apply a FOIL, what are we going to get? Well, let's do first. First can be read, so here's our first one. And we've got A times C, or AC. Then outer can be blue, that's the outer one, so A times D, or AD. Then we have inner, can be green, so the inner two terms, B times C. And finally, the last, we'll do that in black, B times D, or BD. So hopefully that's revision for you on how to FOIL. Well, we're going to be looking at binomial products that involve surds. Surprise, surprise. So now that we've refreshed how to FOIL, let's look at some examples. Alrighty, example 1. The square root of 2 plus 3 multiplied by the square root of 2 minus 5. Alright, let's FOIL. First, square root of 2 times the square root of 2, well that's just the square root of 2 squared. Then we have the outer, that is root 2 times negative 5, or putting the number out the front, negative 5 root 2. Then we have the inner, 3 times root 2, so positive 3 root 2. And finally, the last, 3 times negative 15. Times negative 5, which is negative 15. I'm getting ahead of myself there. Alrighty. Now we've got a couple of things to do on our next line in order to simplify this. The first thing is to realise that the square root of 2 squared is just 2. If we remember back to a previous rule, we learned that the square root of x squared is just x. So therefore, the square root of 2 squared is just 2. And then we can also collect some like surds. We have like surd here and like surd here. Negative 5 plus 3 is negative 2. So we have negative 2 lots of root 2. And then we still have that minus 15 at the end. And tidying up once more, we can combine the 2 and the minus 15 to give us minus 13 minus 2 root 2. And there's our answer to example 1. Alrighty, example 2. The square root, 2 root 3 plus 5 all squared. Now we know that when something is squared, it's times by itself. So we could write another brackets that's 2 root 3 plus 5 and use the FOIL method. But what is a quicker way? What is another technique we can use? Well, in the quadratics topic, we learned about the perfect square. In fact, we actually learned it last year. So let's refresh that. The perfect square. This rule tells us that if we do have some a plus b all squared, it is essentially the a squared, the b squared, and 2 lots of ab in the middle. So let's apply that now. We have the first term, which is 2 root 3 all squared. We have the last term, which is 5 all squared. And in the middle, we have 2 lots of 2 root 3 times 5. Okay, let's look at the first bit. 2 root 3 all squared. Well, that's just 2 squared, which is 4, and root 3 squared, which is 3. 4 lots of 3 are 12. In the middle, 2 times 2 times 5, so just focusing on the numbers, 2 times 2 times 5 gives us 20 root 3. 20 root 3. And finally 5 squared, 25. Let's combine our numbers, 12 and 25, and we get 37 plus 20 root 3. And there's our answer. Alright, example 3. We have 5 examples, by the way. 5 examples. So 2 down, 3 to go. Alright, example 3 is the square root of 7 minus the square root of 3, all squared. So once again, this is a perfect square. So let's use the perfect square rule. We have the first term, which is the square root of 7 squared. We have the second term, which is the square root of 3 squared. And in the middle, we have 2 lots of root 7 and root 3. Now just remember, just adding to the perfect square rule, if we have got a minus b all squared, the expansion is essentially the same in that a squared and b squared are still positive, but we have a negative 2ab in the middle. And that's what I've done here. We have a negative middle term. Okay, whereas the squareds, the root 7 squared and the root 3 squared, they stay positive. Alright, well, square root of 7 squared is just 7, and the square root of 3 squared is just 3, and in the middle we have 2 times root 7 times root 3. Remember that when we have 2 surds multiplied by each other, we can put them under the 1 square root, and 7 threes are 21. So we have 2 root 21 in the middle. Combining the 7 and the 3, we get 10, and there is our answer. 10 take away 2 root 21. Alright, example 4. Might go down onto the next page. Alright, example 4. The square root of 5 plus the square root of 2 multiplied by the square root of 5 minus the square root of 2. Have a little look at that. We could use the FOIL method, But is there something else that you recognise? Hopefully, after seeing the the perfect square, you might remember that there's also the difference of two squares. Okay, that rule states, let's write that out, difference of two squares. That rule states that if we have some a plus b multiplied by a minus b, the result is simply a squared minus b squared. The difference, or minus, of two square numbers. So let's apply that here. It's a difference of two squares question, so we have the square root of 5 squared minus the square root of 2 squared. But the square root of 5 squared is just 5, and the square root of 2 squared is just 2, and 5 take away 2 is 3. So that actually simplifies down really nicely. Alrighty, last example, 5. 5 root 2 minus 7 multiplied by 5 root 2 plus 7. Once again, we have something minus something and something plus something, okay, and a plus b and a minus b. So this is a difference of two squares. So rather than expanding out using the FOIL, let's go ahead and use the difference of two squares rule, which is the first term squared minus the second term squared. Oh, sorry, root 7. That's what it should be. My mistake. Not just 7, square root of 7. Alright. So let's focus on the 5 root 2. When we square that, we square the 5, which is 25, and we square the root 2, which is 2. So let's do that in two parts. We square the 5, which is 25, and we square the root 2, which is just 2. Minus, now looking at the second part, the square root of 7 squared is just 7. 25 times 2 is 50, and 50 minus 7 is 43. There's our answer for the last example. Now have a look at examples 4 and 5. What do you notice about the final answer that we got? Both 3 and 43 are rational. Okay, going back to examples 1, 2 and 3, we got answers that involved surds, and that's fine. But in examples 4 and 5, we got rational numbers. And what was different about 4 and 5? Well, they were both difference of two squares. When we're dealing with the difference of two squares with surds, okay, we call these binomials conjugate surds. So let's just write a little note about that now. These binomials, okay, in 4 and 5 are called conjugate surds. The answer is always rational. Okay, so when we, don't worry about that, comma, when we multiply a binomial surd by its conjugate, the answer is always rational. So conjugate, okay, just rephrasing, I guess, is just a fancy way of saying we've got a plus b and a minus b. Okay, that's all we're talking about here. That's a name given to it. Alright, we'll finish off this sentence. and then we're done. The reason we've written this out is because this is going to help us in the lessons to come. Okay, so just recapping. A binomial product is of the form a plus b times c plus d, and we can expand those using the FOIL method. We're taking the FOIL method and applying it now to binomial products that involve surds. Using some of the rules that we've learnt so far in the surds topic, we can see that something like the square root of 2 all squared is just 2, okay, and we can collect like terms and simplify. We can also apply the perfect square rule and the difference of 2 squares. When we have a difference of 2 squares, we're really looking at one binomial multiplied by its conjugate. And when we have that, the answer is always rational. Okay, hopefully that makes sense. Have a go at the exercises now. Thanks for listening.